All right, so in this lesson, we're going to take a look at rates of change as it applies to business and economic situations. So what you want to be able to understand at the end of this lesson is to be able to recognize these terms such as cost, revenue, and profit, and the functions associated with them. So we'll talk about the cost function, the revenue function, and the profit function for a particular situation. And where the calculus comes in is when we talk about how these things are changing. And we'll talk about marginal cost, marginal revenue, and marginal profit. And we'll also talk a little bit about average cost. Specifically, you want to be able to use these concepts or these definitions to solve problems, and these problems tend to be maximization and minimization problems. So let's start by filling in this little table here where we look at these different functions, how we represent them, and kind of what they mean. So in each of these things, we are going to have a series of functions with our variable x, okay? And x always represents the same thing in all of these questions. It represents the number of units that are being produced or the number of units that are being sold. And magically in these kinds of questions, the number of things that this company produces and the number of things it is able to sell on the free market are exactly the same, okay? It's a little bit artificial, but that's what's going on here. So first off, we have our cost function, usually designated by capital C as a function of x. So it represents the cost of producing X number of units. And we don't know what these units are. They could be any product that we're trying to produce or any product that we're trying to sell. Okay? Now, if we take the derivative of our cost function, so c primed at x, we get what is called the marginal cost, or the marginal cost function. What does the marginal cost represent? Well, it is the change in the cost of production. What this with each unit, okay, with each unit, okay. So usually you can think of this as if you decide to make one more unit of whatever this product is above and beyond what you're already producing, how much is that going to add to your total costs? So we can sort of say that this is the cost to make one more thing of whatever this thing you are making. Okay? So it's the change in the cost. Cost function gives you your total cost of producing all of your things. Marginal cost gives you the cost of producing sort of each additional thing. And that value for the marginal cost changes at different levels of production. At some points, it's really expensive to produce one more unit. Sometimes it's really cheap to produce one more unit. After the cost function, we have to consider the price function, also known as the demand function. And that's represented by small letter p as a function of x. So this is the price that each one of these units can be sold for. Okay? And it's going to change depending on how many units are being produced and how many units are being sold. This is kind of like supply and demand. The more things that are out there, the price tends to go down. The fewer units that are being produced and sold, the price tends to go up. We don't usually talk about the derivative of our price function. What we do need to do with our price function is we usually use it to generate what is known as our revenue function, capital R at x. Okay. So revenue is the total amount of money coming in from selling these X number of units that you're producing or sold. And we can calculate this by taking X, the number of units that we produce or sell, and multiplying it by our price function. So it's the number that we sell times the cost or the price for each one. I'll put multiplication in the middle there. Now, if we take the derivative of our revenue function, we get what is known as our marginal revenue. So marginal revenue is similar to marginal cost. Okay? It is the change in total revenue from selling one more unit. So, and again, this is going to vary depending on the number of units that are the current number of units that are being produced and sold. Finally, we put all this together to get our profit function. Profit function is capital P at X, and our profit is just the difference between our revenue and our costs. So R at X minus C at X. I'll write that a little bit smaller. R at X minus C at X. Okay. So we're all kind of familiar with the concept of profit here. If the value of our profit function is positive, that means we are making money. If it's negative, we are losing money. If we take the derivative of our profit function, we get our marginal profit. So what does marginal profit mean? Well, it's going to be the change in our profit from producing and selling one more unit. So your marginal profit takes into account changes in both your cost function and your revenue function to predict how your overall profit is going to be affected by both your cost of production and the changing price. Okay. And finally, we're going to stick in average cost down here at the bottom. Average cost is like any other sort of average. You take your total cost and you divide it by the number of things that cost that much. Well, in this case, the number of units. So what represents our number of units? That's our variable x, and our total cost is just given by our cost function. So it's C at x divided by x. Okay. So let's take a look at an example here where we're going to use all of these definitions, or a number of these definitions, and we'll try to come up with some conclusions based on what the numbers are telling us. So, based on a 10-year study of production costs, a Niagara winery has determined that the cost of producing X bottles of wine is given by, and they give us this cost function here. So use a function of X. So this is our cost function. Market research shows that the demand for wine is given by this function here. So this is lowercase p as a function of X. So this is our price function, or our demand function. And we are asked 3 questions here. We want to determine the production level that maximizes our revenue. We want to determine the production level that maximizes our profit. And we want to figure out what is the marginal cost at each of these 2 production levels that we have found in A and B. So if it's asking us for a production level, our final answer is going to be a value for X. Okay, because X is going to be the number of units that we are producing here. So let's take a look at the first part of that here. Determine the production level that maximizes the revenue. If we're going to maximize our revenue, what we need is our revenue function. So how do we get our revenue function? R is a function of X. Well, R as a function of X is X times our price function, X times P at X. The number of units we are selling times the price that we get for each one of these units. So that's going to be x times, we're given the price function here in the question, that's 12 minus 0.001x. And we can just simplify this a little bit by expanding to get 12x minus 0.001 x squared. I'm missing a 0. I should have 3 zeros, and I only have 2 zeros. So I'm missing a 0 here. 1, 2, 3, 1. And I'm missing a 0 here. 1, 2, 3, and 1 x squared. Better? Thank you. Well, this is our revenue function. Now, we want to maximize this. We've done maximization before. If we want to find where the maximum value is, or a local maximum for this thing, we're going to take the derivative, set it equal to 0, and solve for x. So, let's take our derivative, r primed at x. So, we're getting our marginal revenue function here, but really we just care about the fact that this is our derivative of our revenue function. So, r primed at x is going to equal 12 minus, let's see, 0, 1, 2, 3, 2 times x, and then we want to set this equal to 0 and solve. So we can solve this pretty easy. We get x equals 60,000. So this is the value, the number of things that we have to produce in order to maximize our total revenue. Okay, the total amount of money that we have coming in. Okay. So let's take a look at part B here. We want to determine the production level that maximizes the profit. So if we're going to maximize our profit, what function do we need here? We are going to need our profit function. So our profit function is, capital P at x is r at x, revenue function, minus c at x, cost function. We know how to get our revenue function. We figured that out in the last question, so we can just copy that over. So that was 12x minus 0.0001 x squared was our revenue function from part A. And from this, we are going to subtract the cost function that they give us in the question. So 12,000 plus 4x plus 0.0002 x squared. And we're going to do the same kind of thing we did before. If we want to maximize profit, we're going to take the derivative, set it equal to 0, and solve for our value for x. Now, to make this derivative a little bit easier, I'm going to simplify this expression by collecting my like terms here. So I'm going to end up with negative 12,000 plus 8x minus 0.0003 x squared. So my marginal profit, or P primed at x, is going to be 8 minus 0.0006 x. Okay. Set this equal to 0, solve for x. We're going to get an x value of 13,333. Now I think that's approximate. I think I had to round that off. So our profit is maximized at 13,333 units. Our revenue is maximized at 60,000 units. Why is there such a big difference between where we maximize our revenue and where we maximize our profit? Well, that's what we're going to look at in part C here. We're going to look at the marginal cost at each of these two production levels. Okay? because that's what it's going to come down to. How much does it cost to produce these units when we're producing 13,000 versus how much does it cost to produce things when we are producing 60,000 of them? So our marginal cost is the derivative of our cost function. Okay? So our cost function is 12,000 plus 4x plus 0.0002x squared. Our derivative, our marginal cost, is going to be 4 plus 0.000 4x. And let's just take a look at our answers from A and our answers from B. So in A, we had a production level of 60,000 units. So C primed, or our marginal cost at 60,000. Now we're just subbing in and calculating. When I plug that in, I get $28. So what does that 28 mean? Well, it's the marginal cost. So it is the cost to produce one additional bottle of wine. So if they go from a production level of 60,000 to 60,001, they're going to add $28 to their total cost of production. Okay? That's how much it costs to make that bottle. In part B, we were at 13,333 bottles of wine produced. Our marginal cost at that level of production is approximately $9.33. So each additional bottle of wine only costs them $9.33 to produce. So our production costs are much, much lower when we're producing 13,000 versus when we are producing 60,000. Okay? So that's why our profit gets maximized at this lower value of production.